Question 4, part A, wants you to solve some LP using the simplex method, and it gives you a hint that you should use the first stage procedure first, and then the second stage procedure second. There's a revision question. When do you need the first stage procedure? Or maybe easier, why do you need it here? In what sense are they mixed? Because there's a greater than. Yes. That is the reason why you need it here. In general, simplex method starts with the starting basis in which all the x's, so all the decision variables, are not in the basis. And so you want that tableau to be feasible, and so what you want is that if you plug in all zeros for all these x's, you want all the constraints to be satisfied. And if they're not, then you will need the first stage. That's the principle. Right? In this problem, when you plug in zeros for all the x's, you see that the second constraint is all right. 0 plus 0 plus 0 is less than or equal to 5. And the third one, 0 plus 0 plus 0, is less than or equal to 6. Whereas the first one is not. You get a 0, which is not greater than or equal to 4. And that tells you that you will need an artificial variable for the first constraint. Okay. Not for the others, because the others are satisfied with all zeros, but the first one is not, so that one will need an artificial variable. And then, once you have that, you can create a tableau in which, well, what will the basic variables be? For the constraints where there's an artificial one, it'll be the artificial one, so that's the first constraint. And for the remaining two constraints, it will be the slack variables. Then you have the usual objective, and then you have the artificial objective. Okay. The val is the right-hand side. So you get 4, 5, 6, and there's no right-hand side for the 0, and I'm not doing the 0 yet. And the rest is 1, 1, 2, minus 4 as you're used to, 2, 2, 1, 5. Now, because the first constraint is a greater than or equal to, you need a minus 1. For the slack variable or surplus variable, rather it's called, you will need 0 here. And the artificial is in the basis. What's the rest of the 0? This is just like simplex 2, the assignment. The rest of the 0, in this case, it just copies the A1 row. In general, you look at all the rows where there are artificial variables and add them together, and that will be your 0. In this case, it's just 4, 1, 2, 1, times 1. Now, for technical questions, you can solve this like that in the exam book by hand, pen and paper, calculator, in your head, whatever. Or you can use Excel if you want, because the exam is in a lab. So if you're using Excel, you can, in your assignments, then in the same way you can use it to solve the exam problem. Okay. What's next? Gosh. What's next? Okay, George, what's next? Yes, we're trying to minimize G, exactly. So minimizing G means, one of the first things I said today, is looking for a positive entry in the objective row. The objective row is now G, well, not including the val. Okay, there are 3 different positive entries that you can pick. You might tend to go for the largest of them. So this is your pivot column. Now you want pivot row, but not in the Z row. So which one do you choose? Well, that depends on ratio test, as I'm sure you know. The ratio is 4 divided by 2, 5 divided by 2, 3.5, and 6 divided by 1, that's 6. So which is the pivot row? First row, exactly, because it's the least entry. So you would do the usual pivot. A1 is replaced with x2 in the basis, S2 and S3, and Z and G are still there. And if you did it really properly, you would see that this is 2, 1/2, 1, 1/2, minus 1/2, 0, 0, 1/2. And then the row reduction to obtain zeros all the way down here would give you that second row of S2 is 1, 0, 0, 1, 1, 1, 0, minus 1. The S3 row is then 4, 3 over 2, 0, 3 over 2, 1/2, 0, 1, minus 1/2. I'm not going to finish it all. Minus 3 over 2, 11 over 2, minus 5 over 2, 0, 0, halves, and half, 0, and minus 1 at the end of the G row. I can do that all in my head so quickly. No, I can only do that because I have the. So what do you conclude now, or conclude? What do you say now? Not quite the conclusion yet. Okay, I'll say that. If you're not concluding anything. G has been minimized because there are no more positive entries in the G row. It's been minimized to 0. It's good. G is 0 means that a feasible solution has been found, which is x2 is 2, and x1 and x3 are 0, and also maybe you can say that x2 is 1 and x3 is 0. Okay. Want. Which finishes the Roman 1 part. We found a feasible solution. Okay, and so what do you do next? So you all need to catch up. But, I will soon lose you anyway. This is the first stage procedure now finished, because it's minimized G, that was its purpose. And what happens next is that you can remove the G row and all the artificial variables, and you get a new tableau like this. And what does the question want to do? Maximize Z. If it wants to maximize Z, you just go on to maximize Z. So you do your normal pivot based on the Z row, and so on, and so on, and so on. Which would look like this. Now we are not all going to copy that into new questions. This is just box standard built-in. The only thing that is different is the first stage, which allows you to find a solution, or if you're lucky to include a version. There would be none if after minimizing G you would still not get 0. Any questions? No? In the remaining 5 minutes, let's solve part B. Part B is about something that we did fairly early in the first booklet study. Remember EOQ formula? You have to remember the EOQ formula to be able to solve this question. And the EOQ formula the EOQ means economic order quantity. And the formula that we derived in the lecture was that the optimal order quantity is the square root of 2D K, I think we said divided by H, where D is the demand rate, A is cost of placing an order, and H is the subholding cost, or cost of storage, if you like. That formula ring a bell? Good. The whole question with 6 marks is just plugging in the right numbers. So you get D equals 300 units per month. That's the demand from the first line. every time you place an order, you incur a cost of £15, and that's this K. The production cost is £1 per item. I don't know what that means, but that's not used in the formula. So that's just there to confuse you. And the holding cost is 30 pence per item per month. So this is H. Now, as you can see, I was very nice to the students last year because it was all in units per month. One thing you should be careful about, if I can't even remember if a question like this is in this year's exam, but if it does crop up, you have to be careful that the time unit is the same. You wouldn't be doing, for example, demand rate per week and stock holding cost per year. So we give you completely irrelevant answers then. So now, if you substitute all these into the formula, you get that Q star is 2 times 300 times 15 divided by 0.3, which is about 173 based on my model solution. What does that mean, this number? Which bit of the question does it answer? How many items to order, which is phrased as the optimal size of each order in the question. So the optimal, now you have to answer the question really and say that the optimal size of each order is 173. How often should an order be placed? Every month. Why every month? No, but you're using 300 per month, and you're only ordering 173 each time. So that wouldn't last the whole month. Okay? So you're on, but you're getting there. So yeah, George?
Roughly 1.7 million, so averaging out.
Yes, so you have to do place 300 divided by 173 orders per month. So what did you say it was? 1.73? Well, that is one answer. How often an order should be placed? That's possibly good enough. Probably you want so the number of months between any two orders is 173 divided by 300. About 173 over 300 months between two orders. Starting because a month is roughly 30 days, that gives you about 17 days, doesn't it? Any questions at all? Probably not. About this